Welcome, dear students, in the fifth video of laws of motion. In this video, I am going to explain about gravitation. Gravitation is the name given to the force of attraction between any two bodies of the universe. It was discovered by Newton in the year 1665 when he saw an apple falling down the tree. Let us see Newton's law of gravitation. According to Newton's law of gravitation, the force of attraction between any two bodies, the magnitude of force of attraction between any two bodies is directly proportional to the product of their mass and inversely proportional to the square of the distance between them. Let us see how. Let two bodies A and B. Suppose the mass of body A is m1 and mass of body B is m2. Let the two bodies are separated by a distance r. Then according to Newton's law of gravitation, I said the force of attraction between these two bodies is directly proportional to the product of their masses. Means F is the force of attraction between these two bodies is directly proportional to the m1 into m2. And one more factor I said, the force of attraction is inversely proportional to the square of distance between them. That is, F is inversely proportional to r square. So when we combine these two equations, so we can write from equation 1 and 2, F is directly proportional to m1 m2 by r square. Or we can write F is equals to, when we are removing this proportionality symbol, we are using a constant G, m1 m2 by r square. So this is the expression for force of attraction between any two bodies, and it was given by we obtained this from Newton's law of gravitation, where G is a proportionality constant, and is called universal gravitational constant. So this G is called the universal gravitational constant, and this is the formula for gravitational force or force of attraction acting between any two bodies of the universe. Let us see the unit and value of this G. As I said, G is a constant, so it has a fixed value, and what will be the unit of this G? So I am going to calculate unit and value of capital G, universal gravitational constant. So as we have seen, F equals to G m1 m2 by r square. So we can write this cross multiplication, F r square by m1 m2 is equals to G, or we can write G is equals to F r square m1 into m2. So let us see, force is measured in Newton, distance is measured in meter, so radius this distance, so r square by, we can write mass is measured in kg and this mass also measured in kg. So SI unit of G will be Newton meter square per kg square. So SI unit of this G is Newton meter square per kg square. If we are writing the value of this G, so we are getting G is equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is the value of G. We can define this capital G. How we can define this G? Let us see the definition of universal gravitational constant, capital G. So what we can write there, as I said, G is equals to F R square by M1 into M2. If M1 equals to M2 is equals to 1 kg, means we will take the two bodies of unit mass and R is equals to 1 meter. Then substituting these values in this equation, we will get G is equals to F. So we can define universal gravitational constant in terms of force. So let us define. Universal gravitational constant is equals to the force acting between two bodies of unit mass and separated by a distance of 1 meter. So if two bodies of unit mass separated by a distance of 1 meter, the force of attraction acting between them is equals to the universal gravitational constant. We can see this value is very small. That's why we are not feeling this force. That means we are also acting as a body and we are not attracted by any other body, as our mass is very small and this G is also very small. So these force we are not experiencing really. But there is importance of the law of gravitation. So let us see what are the importance of this law. Newton used this law to explain the motion of planets around the sun, the motion of the satellites around the planets, and the motion of freely falling body. Now let us see the next point, gravity. Gravity is a special case of gravitation. As I said, gravitation is the force of attraction acting between any two bodies in this universe. So if out of that two bodies, one body is Earth, then the force of attraction acting on the body by the Earth is known as the force of gravity. Means if it is Earth and a body is kept on the surface of Earth or near the surface of Earth, then the Earth pull this body towards its center. This force is called the force of gravity. So as in gravitation I said, it is the force of attraction acting between any two bodies. So in this case, one body is Earth and another is any other body. So Earth is pulling each body towards its center and this force is called the force of gravity. Now the next term is acceleration due to gravity. When a body falls freely under the gravity on the surface of Earth, an acceleration produced in the body is known as the acceleration due to gravity. It is denoted by small g. So acceleration due to gravity, acceleration due to gravity is denoted by a small g, and the acceleration produced in a body when it falls freely, it is the acceleration produced in a body when it falls freely under gravity on the surface of Earth. Next term we will see the relation between small g, that is acceleration due to gravity, and capital G, that is universal gravitational constant. So let us see one relationship, that is relation between small g and capital G. For this we will consider, let Earth to be a sphere with center O, radius capital R. Let a body of mass small m is kept on the surface of Earth, and mass of Earth let us assume capital M. So as we know, this mass small m, the body of mass small m, will experience a force due to gravity. So we know that as gravity pull, that is a force, so we can write it as mass into acceleration. So we know that I have taken the mass small m, and we know I said that the acceleration acting on the body is acceleration due to gravity. So we can write it g. So mg is the force acting on this body, and it is acting towards the center of Earth. And according to Newton's law of gravitation, we know that according to Newton's law of gravitation, we know this body will experience a force due to the Earth, and that force is g, mass of the body, mass of the other body, and the distance between them, that is r square. Let it be equation 2. So these two forces, I said gravity is a special case of gravitation. So it is also the force of attraction between mass m and capital M, that is two bodies, and this is we are getting from Newton's law of gravitation. So both are equal. So we can write from 1 and 2, equation 1 and 2, we can write it as mg is equals to capital G small m capital M by r square. We will get this m cancel, and g is equals to gm by r square. So this is the relation between capital G and small g. If we will put the value of small g in this relation, so let us substitute the value of small g. So we know g is equals to 6.67 into 10 to the power minus 11, and mass of Earth, this is the mass of Earth, so we can write the mass of Earth, that is 5.96 into 10 to the power 24 kg divided by radius of the Earth, that is 6.4 into 10 to the power 6 meter to the whole square. On solving, we will get g is equals to 9.8 meter per second square. So this is the value of small g. As children, we know Earth is not a perfect sphere. The radius varies from place to place. On this equator part, the radius is greater than the radius of on this polar side. So we can just see, if this radius is greater, means r is greater, so g will be smaller. So we can say on equator the value of G will be smaller, and at the pole the value of G will be maximum. Also we can say, if we will travel from pole to equator, the value of G will decrease. So value of G varies from place to place on the surface of Earth. Similarly, if we will find the, as I have taken capital M mass of Earth, if we will do it for the moon, so if we will put the value of mass of moon and radius of moon, then we will get the value of acceleration due to gravity on the surface of moon, which is approximately 1/6 of the value of G as on the Earth. So value of G varies from place to place. Next term we can see certain equations for freely falling body. We have seen the equations of motion in, we know that the equations of motions are there. 3 equations of motions we have seen. So that can be also explained on the basis of on this gravity. So how we can just represent that? We know that equations of motion, V is equals to U plus AT, S equals to UT plus half AT square, and V square is equals to U square plus 2AS. We know these 3 equations of motion. When a body falls freely under the gravity, we take acceleration is equals to acceleration due to gravity. So these equations will become as, that means for freely falling body, we can write V is equals to U plus GT. So A will be replaced by G. S equals to UT plus half GT square, V square is equals to U square plus 2GS. Similarly, if the body, this is for freely falling, if the body moves upward, means if we throw the body upward, that means away from the center of Earth, so the A will change to minus G. So acceleration due to gravity will become negative. And similarly we will put this value, V is equals to U minus GT, S is equals to UT minus half GT square, V square is equals to U square minus 2GS, for when the body moves vertically upward. Next term we can see, that is mass and weight. So as we know, what is mass? Mass is the amount of matter contained in a body. And what is weight? Weight of a body is the force with which the earth attracts it towards the center of earth. So it is gravity pull. That means, as we know, pull and push is force. So it is the gravitational pull. So as I said, mass is the amount of matter contained in a body, and let us differentiate between mass and weight. What is the difference between mass and weight? First definition we can see, mass is a measure of the quantity of matter contained in the body at rest. Weight, it is the force with which the earth attracts a body. Mass is a scalar quantity, weight is a vector quantity. SI unit of mass is kilogram, SI unit of weight is Newton. Mass is measured by beam balance or physical balance, weight is measured by spring balance. Mass is a constant quantity, but weight of a body changes as we know that the value of G changes because weight is equals to mg. So if G will change, weight will change, but mass always remains constant. So these are all about mass and weight. One more term I am going to explain, that is the gravitational unit of force. So what is the gravitational unit of force? In MKS system, the gravitational unit of force is kilogram force. So we can write it as kgf, that is kilogram force. What is this? 1 kilogram force is the force due to gravity on a mass of 1 kg. Means 1 kgf is equals to, we can write it as we know the formula, that is F equals to ma. So 1 kgf equals to 1 kg mass of the body and acceleration is, we can take it 9.8 meter per second square. So 1 kgf is equals to 9.8 kg meter per second square, or we can write 1 kgf is equals to 9.8 Newton. So this is 1 kgf. Next one is, in CGS system, the gravitational unit of force is gram force. That is, we can write, it was in SI, we said it, and in MKS system I said this. And if we will talk it in CGS system, in MKS system, the force is always measured in Newton. Sorry, in SI system, the weight is also always measured in Newton. In MKS system, we have seen kilogram force. Now we can say, in CGS system, again we can put F equals to MA or mg, we can write. So 1 gf equals to mass, we will take 1, we can take the mass that is of 1 gram. So 1 gram into, this is in CGS system, so we can use it 980 centimeter per second square multiplied by 100. So 1 gf equals to 980 gram centimeter per second square, or we can write 1 gf equals to 980 dyne. So 1 gf equals to 980 dyne. This is the relationship between gram force and dyne. So we can say 1 gram force equals to 980 dyne. So this is all about gravitation, Newton's law of gravitation, gravity, mass, weight, and the gravitational unit of force. Thank you, students. Thank you for watching.